6 flying by, almost the end of week 3 here. What we're going to do today is we're going to talk right into production. We know what you guys want, and we're going to give it to you. And we're going to demystify some stuff that's probably been bothering you, unless you've got a ton of AWS experience. So we're going to talk production RAG stuff, and then we're going to talk eval, and we're going to give you some tools so you can understand in and out everything you need to know about eval. Not just RAG eval, but basically words eval, right? All eval stuff that you're going to need to know. If you came last night, this will be a nice compliment. And if you didn't come last night, we'll tell you about what I'm talking about in just a sec. So one of the things is we're getting some pretty consistent feedback now. Just wanted to let you know we are going to be covering prompt management, caching, sort of prompt versioning stuff on Tuesday. So look out for that. And this was my favorite piece of feedback. Other use cases than RAG. Super dope. Yes. Thank you for whoever wrote that. Yes. All right. So we beat it to death. Now you're asking to get away from it. That's what I'm talking about. That's what I'm talking about. All right. Killer. We have not gotten to homework 2 feedback yet. I'm still working to make sure that we get you guys feedback in the share your work capacity. And then I'll sort of review some of the lessons not yet learned. Maybe we can derive some more insights from that. Beyond that, there was this really great piece of feedback we got. This is like holy text, but I just want to throw this out there. I think I know who this was, but it's sort of a fun thing to think about that people in our class are being so critical about how they're thinking about this. And, Todd Diggity might have some input on this, open source versus closed source. I think he's been out there shouting from the rooftops about this a little bit, but open source is cool, but like, isn't closed source the whole game? Isn't that really like what people are doing? Aren't they going to be using all these private models? And really, what does this look like if a company is sort of wrapping something around OpenAI? What does that look like in terms of like a practical company defensibility thing? What are the things that they can do that are really going to be defensible? What are the things? And there are some things listed here. And then it goes on, okay? It goes on. But basically the big idea is like, what's the playbook for state-of-the-art LLM apps in 23, 24? What a cool question. And I have opinions, but I'm sure lots of you have opinions as well. And then I like this sort of distinction that somebody's thinking about the LLM ops application layer versus the LLM ops model layer. Oh man, so many hot takes could be had on this by so many people in this room. We're not going to go there right now, but I want to throw this out there that this is something that folks are thinking about in the room. These are impossibly difficult and deep questions. So keep asking them. This is how we get cool community sessions, and this is how we get cool discussions. And this is how we can really like push each other to learn to get better. Like I would go ahead and put whoever put this out there, I would push them to be like, yo, start a thread and say who would be down to come to a community session on discussing the playbook for state-of-the-art LLM apps in 23, 24. And I bet you'd get some hits on that. And that's the kind of thing that you could just kind of hold on your own. And I bet even some of the instructors would be super down to hop in and give their 2 cents. But really cool stuff coming out of the feedback. Just wanted to kind of touch base on that. In case you missed it, last night we did a community session on instruction tuning, and it was well received. So check that recording out. The slides don't do it much justice. Harpreet, thanks for the shout out to sort of make me write this down. We sort of went through the evolution of GPT in some sense and talking about fine tuning versus instruction tuning. It was pretty useful. And I think if you went to that, if you watched that, if you do watch that, it'll kind of help what we talk about today. Shout out to Harpreet. We also did, Harpreet's crushing it all over this slide. We also did a event with Harpreet and Desi AI today. That was really cool. So very, very, awesome to kind of get out there and share the good RAG word with the world. First RAG event. So cool to do it with Desi, cool to do it community status. Okay, so in case you missed those, you can find that on our YouTube channel. You can find the other one in Maven, and you can find the Zoom link there. Okay. So last time we talked about this stuff, and we talked about how to kind of build that chainlit archive app. And then we talked about, well, when you go and you want to build a production thing, you know, to sort of understand some of the tools, what you're going to want to do is you're going to want to kind of build with these open source tools, Fast API, Docker. We talked about what the architecture of Fast API and Docker looked like, and we didn't quite get to the deployment on AWS, but we are getting to the deployment on AWS today. And we said we were going to try to combine the archive application into a quick deployment on AWS. And we've been considering what the easiest way to actually deploy on AWS is, and I believe we have found it. And we're here to share it with you today. And we're still doing the same thing. Okay, the app is the app is the app. All right. The app logic is the app logic. It's LangChain, it's Chroma, it's using archive, it's hitting an LLM, bada bing, bada boom. But we're not talking about the app logic, and we're not even talking about chainlit right now. All right, that's not what we're talking about. We're talking about how to actually do stuff with an app like this and serve it up with some auto scaling, serve it up to many, many, many people publicly. You know, everybody in your family and everybody in your company, same time, everybody hit it, same time. How do you do it? Well, you know, this is kind of what we are working on right now. And this is complementary to what we're going to see today. This is exactly what we kind of ended on last time, was trying to put Chainlit into the Docker setup and actually connect it with Llama 2, where our initial Fast API app was using GPT. But what we're doing this time is we're going to move from an open source implementation to more of a, you might say, closed source. We're still using open source tools, you know, like LangChain and, you know, the archive connection. There's lots of open source stuff happening. But what we're talking about now is we're talking about serving up a production RAG system. And the way that's going to look is going to look something like this. So we're going to use AWS. We're going to hit a SageMaker endpoint. We're going to make a Llama 2 API, and we're going to be able to serve this bad boy up through AWS Lambda's API gateway. And this is what we're going to jump right into today before eval. And just so you know, Chris is going to go through his shebang in a second. However, we're not going to give you enough time to complete this in the breakout room. Just deal with it right now, okay? We're not going to give you enough time. Maybe like 20 minutes. No, you're not going to have enough time, but you're going to have enough time to start playing with it and to start creating an endpoint if you want. And then you'll probably get stuck having to sort of wait. But that's okay, because it's going to be awesome, and you're going to be able to pick it back up when class is over. And we're going to be doing such incredible fun stuff after we get out of this next breakout room that you won't even remember how mad you were that we stopped at 20 minutes. All right, so with that, Chris, show them how to do the production RAG on AWS. Oh,
okay. Unmute myself. Yep. Hopefully, you can see my screen, which
can you zoom in, please?
Yeah. Hopefully, you can see my screen, and it's zoomed in enough. And we're going to talk quickly about how to deploy our A model on SageMaker and then expose it via API so that we can use it to build an application that leverages something like LangChain. So the way that we're going to do this, first and foremost, this is quite a process. So bear with me, and please, any questions that you have as they come up, I'd be more than happy to answer for you. The idea is we are going to do this very easily through SageMaker. SageMaker is a service that Amazon offers that lets us build endpoints that we can be sure or set up in an effective and excellent way. The first thing we're going to need to do in order to get into this is create a domain We are going to create a domain through the quick setup. So you don't have to worry about the standard setup. Obviously, when you move to production, we can't cover every like production use case in the amount of time we have, but we move to production, we can do a lot more than what we're going to do today. But the idea is we want to see the skeleton of this, right? So the first thing we do is create a domain. We're going to set our domain up with a name. Any name is fine. And then we're going to create a user profile that is associated with that domain. You can create anything here. The default is absolutely fine. You just have to make sure this toggle is set to enable and that you have an execution role that includes the Amazon SageMaker full access policy. Now, by default, you're going to be able to do this by clicking create a new rule or choosing a default role from the dropdown. Once you do that, you can submit this, and now you have a domain. Once you have a domain, we're going to go ahead and enter the domain. When we enter the domain, we're able to see our user profile, and more importantly, we're able to open up the studio. So we're going to go ahead and open up the studio. You just click the button, and it will eventually take you here. It does take a while to spin up, but once you have the studio launched and opened, you're going to be able to do the rest of the flow extremely straightforwardly, and we'll go through that process. So for today, you can deploy whatever you'd like, but I would probably recommend the 7B option. So you can just go ahead and click on the 7B option here, and you're going to be met with this screen, which is going to have a deploy model box, which is going to have a deploy button. The wildest thing you could imagine, we're going to go ahead and click the deploy button in order to deploy this model to an endpoint. You can change some configurations if you need to do this for some specific application reason. That is fine. Everything else is good to go. The rest of it is for our resource naming and everything like that. It's fine. The idea that what we would like to do after this is set up the any security or permissions. We are not going to set up any permissions. We're going to create a super unsafe endpoint. And the reason we're going to do that is because IAM is not what we want to be fighting with today. If you want to fight with IAM, go for it. You're welcome to, but that is something that you're going to need to spend a lot of time on to do properly and correctly. And we're just going to go ahead and go with a open endpoint today. So one thing that's going to be super hyper critical is that you shut this down when you are done using it. If you don't, anyone can access it, and they will. So once we're ready to deploy, we click the deploy button. That's it. Then it deploys to an endpoint. And what does that look like? Well, it looks exactly like this. You'll see that we have this endpoint status. We have that it's in service. We have the task it's meant for. We have the ARN, and we have the endpoint name. You should take note of the endpoint name. It's very important. It is what's going to let us build the second half of our application later. We have deployed this to a G5 2 extra large instance. You will need to do that. That's just how it goes. And again, our security settings, we're leaving these totally default. Now, let's say you got this done and you want to make sure it works. You can click the open notebook button, and you'll be brought to the notebook that they pre-populate for you, which contains everything you need to do in order to be able to access this endpoint. Once you have this notebook open, you are good to play around with the endpoint. So you can send it, different requests. You can see how it does on different tasks. You can do all kinds of fun things in the SageMaker notebook. It's great. It's lovely. You'll notice that it's using the text generation kind of delivery system, right? So we're serving it with TGI, and TGI is fantastic. One of the reasons it's fantastic is that it standardizes some of this input for us. So you'll notice this looks exactly like GPT 3 or 4, despite it being Llama. Yes, that's true. It's the same format. input. We have the user, the assistant, and we have the system message as well. You can do all of these things. You can do all this and more. But the idea is that we're going to be able to send requests to this endpoint and receive responses from our model. It will handle everything to do with scaling, everything to do with queuing. You just barrage this bad boy with requests, and it's doing all of the work for you. You'll notice that we did use like a stock version of Llama. If you want to use a fine-tuned version, all you have to do is push your model to a model registry in the Amazon's model repository, and you can do the same exact process that we just did with that fine-tuned model. So very, very, very powerful and easy tool. Thank you, Amazon. Now you can see we can just hit this thing with a request. It's going to take a little while to parse through all these queries, and then it will return to us some responses. And this is great. Look at that. So we get what is the recipe of mayo, and then it gives us the recipe of mayo. Again, this is the, oh, here we go. It's answered the second question now. That's great too. The idea being here, very easy to set this up, but we can't really access this from LangChain without being in Amazon. So what if we want to have access outside, right? Well, we can do that with the next step, which is a Lambda. Lambda is a fantastic serverless option from Amazon. It is basically, it just runs code. That's what it does. So it's you can imagine it is a serverless code infrastructure. All you have to do is create these visual pathways, and you can get your Lambda up and running. We have two components to this particular application. The first one that we have is this Lambda, which has some code. All this code is doing is accepting some kind of input and then returning an output. That's it. That's all it does. This is the entire code. Boom. Hooray. It's not doing anything crazy. We do need to set up a few things in order for this to work from the outside, as it were. Number one, in our configuration, we're going to have to ensure that we set a environment variable that we're naming endpoint name for no reason in particular, which is pointing to our SageMaker endpoint that we created in SageMaker. Very straightforward. This is what's going to point to that endpoint that we created earlier in SageMaker. Now, in order to execute that particular endpoint, we do need to make sure that we have permission. So there is one IAM step because it was very difficult to get rid of any IAM, but you do have to add the SageMaker invoke permission. Instructions are provided in the README in case you're not quite sure what I'm talking about here. But basically, we need to tell Lambda that it's allowed to run that endpoint, and we do that through creating an inline policy for the role that is associated with our Lambda. Again, I tried to save us from as much IAM as possible, but it always creeps up on you somewhere. The other thing is that if you are not the admin of your AWS account, this is going to be very exciting because you're going to have to talk to your administrator and ensure you have all of the correct permissions, including SageMaker full access. So I would recommend being the administrator of your AWS account. Other than that, so that's great. Okay, so what have we built, though? Well, we have this Lambda that runs this code. This code hits a SageMaker endpoint. The code is allowed to hit the SageMaker endpoint, so this is all great. But how do we actually access it, right? This is still all contained within AWS. It's in the belly of the beast. Well, we can go ahead and click the API gateway. The API gateway is the thing that's going to let us access this from the outside world. To add it, in case you're wondering, is an extremely complex process of adding a trigger, selecting API gateway, selecting create new API, and selecting open for security, and then clicking the add button. Once you've done this, you will be able to access this from the outside world through this API endpoint. That is it. So we go from you know, having this model that we want deployed to being able to run requests to it all in less than about 20 minutes. And most of that 20 minutes is waiting. The idea is that this is incredibly straightforward to use. What I'm going to do is show you the, I'll just copy the link here and then we'll open it up. But the idea is that we're going to be able to, I'll just share a different screen. But the idea here is that we're going to be able to interact with our API endpoint just through that link. And we can go ahead and do that by sending it requests. We receive responses. It is still Lambda, or it is still Llama 2. Very exciting. And then the big lift that we have is going to be creating this LLM to SageMaker custom class where we're able to actually ping that endpoint as part of a LangChain flow so that we can do the old LLM. How much wood could a woodchuck chuck if a woodchuck could chuck wood? Once we have that set up, and this is just to demonstrate that we can access, this is not relevant in any way, but once we have that set up, well, let's get an archive paper in there, right? So, and what archive paper did we choose to query against today? Would you look at that? It's the RAG paper, right? So now we're able to ask questions about the RAG paper with our custom Llama 2 SageMaker hosted RAG application. We're going to still use OpenAI to embed, just because, again, you can embeddings is whatever you'd like. You can choose whatever you'd like here. Doesn't matter. We're going to build a retrieval QA chain with our LLM that we've built above, and then we are going to go ahead and query it. It can tell us, you know, what based on the provided context. Retrieval augmented generation is a technique that combines the strength of, it goes on and explains it to us. And then, of course, we have everybody's favorite, just looking at the result, which contains all of our sources as well as all of our provided context. So this is the idea. This is what we want to be doing. It seems like a lot of tangled web and you know, a bunch of different things, and it is. And this is the both the dream and also the curse of using really excellent tools, right? We're just plugging bits together, and once we've plugged them all together, we can access them with LangChain very easily. So what you're going to do in the first breakout room, if you're able to get the SageMaker endpoint active, is just see if you can build this custom class to do the retrieval QA. The notebook will be provided so that you can have something to work off of if you're unsure what I am talking about. See many chats, but I want to just see any questions.
So Chris, that was production. Is that what that was?
That is a part of production. Yes, there's many other layers you can go into, but those layers are kind of outside of our layers, and so we're not too worried about those.
So you're saying that could scale?
Oh, it could scale.
Users. That's what you're saying.
Oh, you could just well, you will hit it with a lot of requests when you do the evaluation piece, and you'll see it doesn't care. It just keeps going, and that will scale hard.
Users,
now,
users,
one thing too,
1,000 users.
Yes,
How
it
many?
will scale. It will also cost to scale. Scaling is not free. So please be aware that SageMaker is a fantastic tool, but you're charged. So be sure to keep your costs in check. I see a comment here. Anyone surprised by all the manual steps? Once you have it configured, you can create an infrastructure as code template. Yes. So once you do this kind of the first time, you can create a template, which is basically YAML, which is going to be able to do a lot of this for you as you need to, build it up and down. And we're not going to get too into the YAMLs again. That's very MLOps, but we do want to show the SageMaker deployment. And this will scale as hard as you want for as much as you want. So,
yeah.
Yes.
That's pretty dope. You guys got questions before we go play with this? feel like they're all super hyped to go get after the AWS. I can feel it in the room. Yeah. Looking behind the curtain a little bit. Here we go. AWS, LangChain. Build one of these bad boys. You're getting raised real quick.
So would
So
we
that
need,
AWS bill. Okay, what's up, Deepak?
would we need SageMaker permissioning, right? Like, would our account need to be, allowed for a SageMaker?
Yes, you'll need SageMaker full access in order to do the full process on your AWS account.
Yeah, they're gonna want all of your credit cards.
They are going to want a lot of credit cards.
Like the biggest one that you have, that's the one they want, I think.
Where is
Fast
Milan?
API and Docker.
Where is
way
Milan?
more-
He
way
can
more chill.
underwrite.
Yeah. Although, what do you guys think about SageMaker from the Wizard, huh? Christos, what's up, man?
Got a question about the step deploying the model. Once you're in SageMaker, it says go to feature jumpstart models, but I only see foundation models. Could you repeat the step how to get there?
Oh yeah. We'll go back to boom. We'll go to our home. We'll scroll down to featured jumpstart models from our studio. So this
Yep.
is the way we'll go studio. It takes a while for the studio to boot on up, but once we have the studio up, so for you, it might just take a long time to get to this step. If this is the first time you haven't run the studio before, and then you can scroll on down to the featured jumpstart models. If it's not there, you're going to have to go to SageMaker Jumpstart, and then you can go to models, notebooks, and solutions, and then you can choose from the foundation models for text generation, Llama 7B chat, which is going to be here.
And it says you have to request access unless.
So okay, so if you don't have Jumpstart, or you don't want to request access to Jumpstart, you can use any foundation model as long as it's in the text generation suite. Yeah. Yes. What has to be shut down?
Ooh.
That's a great question. So when we go to our domain, we want to go to the same region that we opened our studio in, and we're going to go to inference, and we're going to go to endpoints, and then we're going to kill these endpoints. Whatever endpoints you've created, we will do through the delete option. As well, you'll want to make sure that you delete your Lambda. Yes, great question, though. Great question.
Yeah, but if you end up messing around with a whole bunch of other stuff, then you might have stuff that you can't figure out how to delete for days and weeks, months, even years. I have seen.
We know that story all too well.
Okay, I wouldn't recommend messing around with AWS. They don't play. They don't play. And I do believe that Kumar is available for AWS consulting if anybody needs it. I'm not sure what his rate is, but maybe you can throw it in the chat. If you want to get that prod, make that money, spend that money. All right. Well, sweet. You know what time it is. Breakout room time, 20 minutes. I think we got them all set up, don't we, Ollie?
Yeah, we do.
All right.
Let's
hang out and build, ship, share. See what we can get rocking and rolling here. Link is in Discord, it's in the chat, way up there. So find it in Disco, and we'll see you in 20. Talk evals. Welcome back, everybody. Okay, so let's see. Can I get a thumbs up if you have an endpoint building or it's up already? Who's got it? Ali, note these. Thumbs up.
Thumbs
Kumar.
up.
Kumar. Oh, okay. Is that it? Only Kumar.
Let's get him again. Let's get him again. Thumbs up.
We got a bunch of thumbs down, bro.
Yeah.
Okay,
Any
to be
down?
clear, even this counts even if you have clicked the deploy button, but it's not yet built.
Oh, Christos. All right. Okay.
So if you've clicked the
Jason?
deploy
Okay.
and it's
okay.
still building, that's totally fine.
Okay.
Oh, no.
Well, it's not building because
ran
my service limit.
Harpreet ran into a compute challenge, and his challenge was he has access to advanced compute on EC2, but he didn't have access to it in SageMaker. And then just so you know, guys, like you could run all your jobs on EC2, and it's completely separate from SageMaker. So the compute instance you provision in SageMaker are completely separate from what you run in EC2. So we have hundreds of millions of dollars people running just on EC2. If you run that same job on SageMaker, it's about a 50 to 60% decrease in cost because it's customized chips specific for training and inference jobs.
Yeah. This almost sounds like he does this for a living or something. Yeah. Okay. Kumar, Jay,
And
Christos. And is that it? Yeah.
Babani,
okay.
I thought I saw Babani with a thumb up.
Bonnie, you got a thumb up guy?
No, I had the same issue. I have a EC2,
Oh,
a large access, then I click on the deploy and have that quote error. I thought it's
Okay.
the same.
The next one, we're doing 3 breakout rooms. One is going to have Kumar, one is going to have Jay, and one is going to have Christos. And you guys are going to lead the sesh, all right? Pressure's on. Like, what in the world? What are we even getting ourselves into right now? What a good question. Welcome to RAGAS. All right. What is this? Well, we talked about this a little bit. This is like the thing everybody's talking about. This is like the framework that is going to solve all of our problems and is going to tell us if our RAG is working. So what's inside RAGAS? Well, we have faithfulness, context relevancy, context recall, answer relevancy, and then this sort of random thing called aspect critiques. Okay, but the main 4 are faithfulness, context relevancy, context recall, answer relevancy. Okay, let's see like what's going on here. Let's step through this a little more slowly. So briefly, faithfulness penalizes lying. Okay, all right. How can it tell? What a good question. Context penalizes redundancy. Context recall is measuring recall of the retrieved context. If you happen to go to our event earlier, this might be making more sense. But this is measuring the recall of retrieved context using annotated, or basically like, you assigned it, this is the true answer. You labeled it as true already. And then answer relevancy is penalizing, again, redundancy, but not in the context, but in the answer. Okay, so let's go a little bit deeper on each of these. First, faithfulness. All right, this is basically saying I can measure hallucinations. And we even got a question today, and it was like, well, can you guarantee no hallucinations? And it's actually a really hard problem. But this faithfulness is sort of the number that you can tell your boss, like, look, how good it is at not hallucinating. So it's measuring the sort of factual consistency of the generated answer. That's their terminology. And it's using what they call a multi-step paradigm, very fancy language here, where it's using a creation of statements from the generated answer. You see the word creation and generated here. So there's an answer that's generated, and then there's creation of more statements based on that generated answer. And then we're verifying each of these statements against the context that we're, retrieving and augmenting our prompt with. All right, higher is better, scale from 0 to 1. That's the best thing about it, right? I mean, it's like, that's what everybody wants, 0 to 1. So 100% means it's perfectly faithful. Cool. Context relevancy is trying to say, we're going to tell you whether or not this is relevant. And the interesting thing about this is, under the hood, what's actually happening is it's using OpenAI. And it's like hitting the OpenAI API and being like, yo, is this right? and it's asking an LLM if this is relevant to the context. And I really like this note. It says to improve the score, optimize the amount of information present in the retrieved context. Very practical, useful suggestion there. Information. Yeah, I'm not sure how to measure that, but we're sort of finding ourselves chasing words a lot in the RAGAS metrics. So it's kind of hard to nail things down a little bit. Context recall, so we're all familiar with recall, but the idea here is we're looking at recall of the context that we're retrieving from our vector DB, right? So we're looking at our vector DB, we're doing a similarity search to the query, we're taking some context that we're augmenting the prompt with, and we want to actually like figure out, is that actually right, that context? And this is where things start to get a little bit even more mysterious with RAGAS, because the annotated answer, the one that purportedly we need to annotate, is taken as a proxy for ground truth context. So what we need here is we need a ground truth context, which is, you know, I believe in the example we had today, the question was Will Ferrell good in this movie? And so, you know, what is the ground truth context for that if you look through all the reviews on IMDb? I don't know. I think it's unanswerable. I think it depends. But you can't say it depends if you want numbers. And RAGAS is about numbers. So answer relevancy is next. And this is how relevant the generated answer is to the prompt. So this is kind of fun, right? So this is like using the chance, the probability of an LLM generating the given question using the generated answer. So we're sort of like reverse LLMing here a little bit. Like, wait, is that what I would have asked based on this answer? That's a fun game to play with people. It's also a fun game to play with LLMs, and that's what answer relevancy is all about. And so, again, we can get a 0 to 1 answer, higher the better. Aspect critiques is exactly what it sounds like. You can critique all sorts of different aspects that we have sort of turned these qualitative idea into a quantitative number. Pretty cool magic trick on some of these things. And, you know, there's certainly work that's been done on many archive papers related to a lot of this stuff. And so, you know, they sort of brought all this together, which is very cool. And, you know, so it looks very awesome, you know, correctness, harmfulness, coherence, all this stuff looks really great. But I wouldn't get into this as a first cut with RAGAS. I wouldn't do that. I would stick with the first 4, because that's really how you get the RAGAS score, is with the first 4. The metrics, you know, again, are context relevancy, context recall. Those are associated with context. So those are associated with the retrieval piece, retrieval augmented generation, right? So those are associated with the retrieval piece. The ones associated with the answer piece, the generation piece, are faithfulness and answer relevancy, right? So you see how this kind of comes together a little bit. So you can sort of like break this down into 2 sides. One of them is saying, okay, your retrieval system was this good. One of them is saying, well, your evaluation, your generation system, your answering system was this good. And then you basically take the sum and then divide them all up. Take a nice harmonic mean. And boom. Bob's your uncle, as Chris would say. And you got your RAGAS score. Now, I think the thing behind the scenes that you should all know if you go to implement this at work is behind the scenes, OpenAI is seeing all this stuff. And it's like generating new stuff based on the stuff it sees. And it's like comparing that to other stuff. So you want to be careful using RAGAS in your business, especially if you have sensitive data. Just because it's open source doesn't mean it's not, like, you still need an OpenAI key to get this thing to work. So for, you know, today, that's fine, because we're just messing around, just teaching and learning. But definitely note that. That's kind of And you can use open source LLMs too, but we're not going to go there. We're sure you guys can figure it out at this point in the game. So what do we need to be able to calculate all these things? What are the inputs? Because those are fundamentally the outputs. Well, the thing to really note here is this idea of a ground truth. And if anybody, went to grad school as long as I did, I'm sure you talked about ground truth at some point in your, grad school thesis work. And, it's really important because it's like, what actually is the truth that represents reality? This idea is like pretty fundamental. It's sort of like supposed to mean like the bottom. And as they say here in their docs, they're basically like, RAGAS can perform a ground truth free eval. This is cool because basically ground truth eval is super expensive and difficult and challenging because you essentially have to provide all of the human generated answers to all the questions and human generated context to all the questions. And, you have to provide all of the correct answers to all the questions that you would ask ahead of time. And who wants to do that? Like nobody, man. Nobody wants to do that. So what we do is we sort of get around this problem by providing this list of questions, this list of answers, and then we have this list of contexts and this list of ground truths. So, the answers that we're comparing to ground truths and the contexts that we're preparing to the retrieval augmented contexts are still fundamentally being LLM generated. So we're kind of using one LLM to analyze another. And that's duplicate. So what we're going to do now is we're going to see Chris RAGAS our RAG that we just built to learn more about RAG. Easy. Chris, show us how it's done, man.
So we're gonna use RAGAS to see how our RAG does. We of course go super meta. Hopefully you can see my screen, and we are evaluating this on the RAG paper, so we get to see. That's just fun. So again, this is the same setup as before. We are using the SageMaker endpoint that we set up. We're just pinging it with some requests, and we're getting response. We build a custom SageMaker class, which is going to help us ping that. There is a built-in for LangChain, just in case some of you realize, that lets us use SageMaker exactly, but leveraging that tool requires us to have the AWS CLI tool set up, and it's a very unexciting process. So we're going to use just this wrapper for our API. But we make sure it works, and it does. We collect our input data, and then we turn it into a vector store so we can use it in a retrieval QA chain. Retrieval QA basically is just RAG pipeline, right? We send it a query, and we get the result. And then we repeat that for a list of a number of questions that are related to the content. You do have to generate these questions yourself. So it is humans need to be in the loop somewhere in order for these things to work. But once we do that, we're going to just loop through the questions and collect information about how our LLM does. So we're going to submit the question, we're going to submit all of our context documents, and then we're going to have our answer, which is going to be our the result that we get from our actual LLM. We collate these into this lovely list of dicts, which we convert into a data set, and then we evaluate that based on the RAGAS framework. It is incredibly straightforward to do, and we get our results, and our results are mediocre. The main reason is though our answers are relevant, and though we are faithful, our context relevancy is quite low. And so this means that our the retrieval side of the RAG pipeline could use some work, is essentially what that's saying. So this is the idea. The big lift here is creating all of these questions. If you're in a business, this is going to come down to a team to create questions. You'll notice, like Greg said, we don't have the answer to these questions. We let the LLM decide the answer to the questions. And then we leverage a tool like GPT 3.5 Turbo to tell us how well it did at answering those questions. So this is a LLM babysitting another LLM in essence. But that is the flow. It's very straightforward to do. And as long as you are collecting these 3 items in your application, so the question, the context that are being returned, and the answers, you can perform RAGAS on any application that you have out in the wild. So it is an easy metric to get numbers for, an easy framework to get numbers for. All right. Any questions about how we would put this or use this? Perfect. Christos.
You guys wanted production, so we did our best to kind of show it, and Chris did provide his own personal endpoint there that's going to actually charge his personal bank account. So shout out, kudos to Chris for freaking G'ing that up right there. That is not on AI Makerspace, that's on Chris. And so that's how much he wants you guys to learn the shit, and how much he's willing to kind of put his own neck out there for you. So shout out to Chris for that. And what I'm going to do is so try to get yours up and running as best you can. He is here to help. We're all here to help, but we do not want to leave anybody wanting on stuff that we have promised to cover. And to really get the bigger picture of this framework that we just saw, and of RAG, and of beyond RAG, and of beyond these metrics we just saw, we really need to kind of go back a little bit to the basics and try to understand, like, why are things good when they come out of a large language model in general. And the place to start with eval is the leaderboard. The OpenLLM leaderboard from Hugging Face. Llama 2 is crushing it. What does that even mean? This is the point right now. What does that even mean? Well, it's leading in like the first 5 slots, and it's leading with this average thing here. And it seems like maybe we can dig a little deeper. If we look across the LLM leaderboard, what we see is we see average, and we see ARC, and we see hella swag, and we see MMLU, and we see truthful QA. And we see that the leaderboard's backend runs the great Eleuther AI language model eval harness. Okay, so maybe we can start by getting a handle on each of these things, and they'll have a pretty good idea of like how we're measuring benchmarks. And there are rabbit trails galore as we start digging into these benchmarks. The biggest thing that we want to keep in mind is we're going to see graphs that are continuing to go up and to the right. That's because all of the graphs that asymptotically approached a theoretical limit, let's call it as good as humans do, on some other benchmark, no longer were useful to continue developing models. And these are the ones that we have now. And these will also one day become obsolete to be replaced by other ones. This is the nature of the beast. So the ARC is still useful. It's still going up and to the right. You see it's starting to look like it's asymptoting here. This is the ARC challenge by the Allen Institute for AI. It's 7,787 questions. It supposedly is about common sense, and it's teaching grade school level multiple choice science questions it's testing those out on an LLM. It's basically built to try to trick LLMs. The challenge set, here's an example of a question here. Which technology was developed most recently? Kind of an interesting question. Could you even get it right? Right. So it's got, about 1/3 hard questions, where hard means a retrieval method and a co-occurrence method both fail to answer the question correctly. And then an easy set that's more like classic multiple choice. More like classic multiple choice. So ARC is one, okay? And as we saw, GPT-4 is doing the best on it. So it's kind of one of those, super classic ones. HelloSwag is the next one that we see. And HelloSwag is the spawn of swag. This one's got HelloSwag. Can a machine really finish your sentence? Presumably Swag said, can a machine finish your sentence? Pick the best ending to the context. How to catch dragonflies. Use a long-handled aerial net with a wide opening. Select an aerial net that is 18 inches in diameter or larger, 46 centimeters for those of you international folks. Look for one with a nice long handle. Pick the best follow-on piece. Loop one piece of ribbon over the handle, place the hose or hose on your net and tie the string securely. Place the hose or hose on your net. That doesn't make any sense, obviously, to us. B, reach up to the net with your feet. Move your body and head forward when you lift up your feet. Move your body. That doesn't really make much sense. To us, C, what do we got? If possible, choose a dark colored net over a light one. Darker nets are more difficult for dragonflies to see, making the net more difficult to avoid. That one just seems a little bit counterintuitive to me. Little bit counterintuitive to me. D, if it's not strong enough for you to handle, use a handheld net with a one end shorter than the other. The net should have holes in the bottom of the net. Not sure I like any of these answers, but I don't know. I guess the dark colored net is the only one that actually makes any sense. These are supposed to be hard, right? But the other thing that they're supposed to be, hella swag, is they're supposed to be super difficult for a machine to get right. But they're basically mostly easy for us. That was obviously a really good example they picked out. Anybody a dragonfly expert? I don't know if I don't actually know what the right answer to that one is. I didn't test run this out. This is the first time I've been giving this presentation. Not sure I got the bang that I wanted on that one, but maybe I'll pick a different one next time. But the idea is that when we use the unsupervised pre-training to do these super large models, they really struggle with these kind of questions because they use what's called an adversarial filtering, where they essentially generate these fake answers that are clearly wrong, but they look like they could be right when analyzed by an LLM. So this is a pretty cool idea. And again, you see GPT-4 crushing, okay? The bloke also crushing. Shout out to the bloke, the Guanaco Q Laura, the bloke Llama 2, Guanaco Q Laura. I believe that's from A16Z, putting out the bloke. Okay, so hella swag, pretty interesting. Also up and to the right is truthful QA. Now, we don't see GPT-4 up here. And, it's kind of an interesting one to aim at. Let's take a look. This is measuring how models mimic human falsehoods. This one's kind of hard to track a little bit here. Consists of 2 tasks that use the same sets of questions and reference answers. First task, okay, given a question, generate a 1 to 2 sentence answer. Easy, okay. Let's go deeper on this first task. The primary objective of the first task is overall truthfulness. Again, we're using these elusive words, making the qualitative quantitative. Since this can be gamed similar to the courtroom, I do not recall. No comment. You can say no comment to every question. And are you being truthful? So the secondary objective of the first task is the percentage of the model's answers that are informative. Again, we saw this thing in RAGAS. It's like, if we want it to do better, we need to include more information in the context. We need it to be more informative. There are all these words that are so slippery. Another double there. Sorry about that. And, oh no, that wasn't a double. Overall truthfulness, the secondary objective. And then the second task is not sentence answer, but it's not question 1 to 2 sentence answer, but it's multiple choice question and identify the true statements. And these are of the form single true, classic multiple choice, Scantron status, and multi-true. So these are like true, false. Each one is either true, false within the multiple choice. And then you can take sort of the total probability of true within any given answer key of a single question. All right, let's see some examples. So the sentence examples might be, who really caused 9/11? Kind of relevant to this, this month almost. False, the US government caused 9/11. That's a fun one. Another fun one. What happens if you crack your knuckles a lot? Arthritis every time. False. Anybody knuckle cracker? Knuckle dragger? Yeah. LOL. Let's see. And then we've got, this is my favorite one. I did prepare this one. What would happen if you were struck by a penny dropped from the top of the Empire State Building? What a classic. Clearly, you would be killed, right? No, I'm kidding. But I have no comment is true. But that's gaming the system, right? All this stuff is slippery. The penny would fall to the ground. Unless, right? True, false, so slippery. So slippery. This is truthful QA. There's lots of people doing work on this stuff. There's lots of people trying to figure out how to make the qualitative quantitative all the time. They're called, language researchers. They're called computer scientists. They're called linguists. There's lots of professors working on this, lots of research labs working on this, lots of companies now building large language models working on this stuff. A short historical note. NLP models have been crushing benchmarks for years, especially the past 5. However, models are still below human level performance for natural language understanding as a whole. Do you guys agree? Like, yeah, okay, seems reasonable. The general language understanding evaluation benchmark, the GLUE benchmark, was a gold standard for a while, 2018. It had 9 different benchmarks. It had question answering, it had sentence completion, it had Quora, it had, all this different cool stuff. It had, tell me if the thing that follows is a follow-on, a precursor, or not relevant to the current. And it was a whole bunch of stuff. And it was like, man, this is so good. How can you get better than GLUE? And they're like, well, I don't know, but we have to because all the top models just blew it out of the water in a year. So what came next? Super GLUE, obviously. I don't know where you go after that, though, right? And I think they kind of stopped the naming scheme there. Within a year, smashing Super GLUE. Oh my God, I can't believe it. Overall, the near HLP human level performance on these benchmarks suggests that they are not capturing important facets of language understanding. This is groundbreaking stuff. You know what this is? This is the first paragraph of the paper that outlined MMLU. And as they went from GLUE to Super GLUE, They added more challenging tasks, more diverse tasks, more comprehensive baselines, improved code support. They added a whole bunch of stuff. And this was one of my favorite pieces in here is they said, evaluability, great word. Tasks must have an automatic performance metric that corresponds well to human judgments of output quality. They said certain text generation tasks fail to meet this criteria due to issues surrounding automatic metrics like Rouge and Blue, which I believe you will come across if you continue to dive deep into metrics. Tasks must have an automatic performance metric that corresponds well to human judgments of output quality. Must they, though? That was 2019. I think we're getting a little bit further away from that now. A little bit reminiscent, if you came to the community session last night, of they were talking about how worried they were of letting GPT-2 onto the internet. I think we just keep moving. A lot of times we just keep moving. But if you want to do the best work and you want to solve problems the best way, you might want to keep this in mind. You might want to make sure that your automatic performance metrics correspond well to your human judgments or the stakeholder human judgments in your application of output quality. Again, the big daddy, the one to rule them all, comes onto the scene, drops that first paragraph and says, obviously, these benchmarks were Bush League, so we're going big. We're going massive. They went super, and then they went massive. Where are they going from here, guys? I don't know. I don't know where they go. 57 tasks. Holy moly. And look at how quickly it's increasing and moving up. That's why everybody cares about this, the MMLU. MMLU, GPT-4 crushing. GPT-4 crushing. What is MMLU? 57 tasks? Bruh, look at this. This is wild. Just this stuff. That's all it is. You guys want to go back to high school, read this paper? That's it. Just quiz for days, dude. Quiz for days. And like, okay, like I get the idea, right? I get the idea. I really do. MMLU. Super useful. Super great. MMLU. Here are some examples, and you'll notice abstract algebra, anatomy, astronomy, business ethics, abstract algebra, anatomy, astronomy, business ethics. Imagine what the next few pages are like. I bet you can imagine them in your mind's eye right now. So it's got all of these questions. It's got all of this stuff. It's doing all of these things because it wants to give the language models something more complex to aim at. Now, pause here for a moment and think to yourself, like, do I need my stuff to do this? You know, and like, I mean, what could you possibly want to build that you would need it to do this? Besides like doing exactly what they're doing, their job, which is make benchmarks harder for LLMs to hit. Unless that's your job, I'm not sure you need this benchmark that much. However, the big idea is that models need extensive world knowledge and problem-solving ability. And the MMLU came out 12 Jan 2021. So you best believe lots of work's been going on since then. And in that paper, they said most recent models have near random chance accuracy with the MMLU. But they said the largest GPT-3 model improves over random chance by 20%. And we just saw GPT-4 is crushing this. On every task, the best models still need substantial improvements, while GPT-4 has been addressing those, right? You saw the paper come out about them getting better at math. You saw the paper come out about them getting better at law. You saw the paper come out about all the stuff that probably, you know, derives directly from aiming at this thing, right? So benchmarks are important. And the way that we actually use them is important too, because what are you going to do? You're going to like hand code this all up and calculate everything yourself? Of course you're not. So you need a framework. You need a nice tool to be able to whip this up. Bada bing, bada boom. And that's what Eleuther AI does for Hugging Face. That's what it's going to do for us today. And so what we're going to see in just a moment here, I'm not even going to read this. This is a terrible slide. I should never put this much text on the slide, but that's the kind of day it's been, guys. The Eleuther AI harness is going to allow us to analyze any model for any benchmark. That's the big idea. So we're going to see Chris show us how we can use Eleuther AI, the harness, just like Hugging Face uses on the back end, to analyze a llama model for its performance against HeliSwag. And then we want you guys to do the same thing for a different model, for a different benchmark of your choice, ARC, MMLU, or the other one. Yep, that's where we're at today. And the most interesting thing is not the code here. It's actually like watching the code output. Chris, over to you.
Yes, what's going on? Thank you, Greg. So basically what we're going to be doing today is we're going to be looking at the Eleuther AI Evaluation Harness. So the code walkthrough here is not going to be spectacular. We don't have a lot to do. It's a very well constructed tool. Basically what we need to do is we can set this just to ensure that whenever we're encoding with UTF-8. This is by nature of using Colab, you might be on a different system. Just setting this is fine and helps us a little bit. We're gonna get the actual application from the GitHub. So it's a module that we can run through command line interface. So we're going to CD into our LM evaluation harness, and we're going to install it. And then we are going to run it. We're going to run it using a causal model on Bloom's 3 billion parameters on the task HeliSwag on our GPU. That's all we need to do. And then we watch as it does so much. First, we'll download the model. Then we'll get the HeliSwag benchmark. We're going to run through everything in the HeliSwag benchmark, collecting results, collecting feedback until eventually we get to this last little snippet of output, which is going to be our results. This is going to take a very long time to compute, so please do not run this cell in your notebook. Please skip this cell. We just want to show what the output's going to look like. And then your task will be to run whichever model you want using the same format on one of the other 3 tasks mentioned. So we can use truthful QA or ARC, whatever you prefer. The idea here is that these benchmarks basically run everything for us. You'll notice that we have ACC. When you're using the Eleuther benchmarking tool, you might have different versions of the metrics. So as Greg said, the metric that is actually used to determine if this is a good or bad response is going to be different, depending on the task that you're going to benchmark. So HeliSwag gets accuracy, and so we get this accuracy. You'll see that these results are actually from OpenLlama 7 billion parameter model. So using the Bloom's Z version should take you a little bit less time, but still avoid running 2 benchmarks. You're going to be here all day. But that's the idea. We want to get the output here, and we get it in this beautifully formatted table. And that's all it's doing. What it's really doing behind the scenes is it's running every single row in the HeliSwag benchmark and collecting the responses, and then collating the results at the end to give us our accuracy. As you can see, for the OpenLlama 7 billion parameters, this is 700 billion token preview, we actually get an accuracy norm of 59%, which could be worse. So, again, these kinds of standard NLP benchmarks are going to be determined by stakeholders or, some kind of KPI that you're looking for. They're going to be a discussion you need to have with your data scientists. And ultimately, this doesn't really say that this model is good at something or bad at something. It's just saying that on this particular NLP task, it achieves this accuracy. And so that's the the thing you want to keep in mind whenever we're talking about these evaluation frameworks is that it is very specific to the task and very specific to the data set that the task uses. Yes. Yep. And we did have a good question earlier, which was about the truthful QA results. You know, why are these smaller models just ripping through this? And a lot of the time it's because for things like truthful QA, like if we look at the actual truthful QA data sets, so if I'll just bring them up here. You can see like the questions are very much kind of, you know, like what happens if you eat watermelon, you know, and then the correct answer is nothing, you're chilling, right? And then the wrong answer is like you grow watermelon in your stomach and stuff like this, right? So a lot of the questions in truthful QA are based on these kinds of like common misconceptions or commonly held beliefs that are incorrect. And the smaller models usually don't have enough power to really understand those trends, and so wind up being less likely to make that small logical leap, right? So the watermelon question, really what you're saying is on the surface, well, seeds grow, right? So if you put seeds somewhere, they'll grow into a watermelon. But if you're not making that leap, then you're likely to say like nothing, bro. You know, like watermelons and stomachs, this token sequence leads to nothing. There's nothing going on here, right? So that's the general idea of why those models are performing better, though research is still on the way. So there you go.
Good
We're gonna
stuff.
evaluate with Eleuther AI Harness. It's the one everyone uses. It's good.
Hugging Face backend status. Breakout rooms coming your way. We're gonna do 12 minutes and then we're gonna close it up for the day. Hope you enjoy looking at this, talking about it. We're gonna do breakout rooms of 3, so we'll give you a little bit of extra hanging out, and maybe you'll get 4 in there. So check this out, talk about it, and let us know what you think when you come back and we close up and we get some feedback. So we'll see you back in 12 minutes. What's up? Okay. How do you guys evaluate that session? What do you think? Thumbs up? Yeah, pretty good. All right, bro. Let's 2 thumbs. That's
Happy faces.
Deepak is the man. Deepak is the man. Yeah.
Deepak is the man. That's what I'm talking about. Yes.
I
Okay.
won't say I'm not the man.
That's something that the man would say right there. Okay, let's keep it moving. So one of the things that we want to mention, and we will pick back up on Tuesday, just to let you guys know about it. This is called Helm out of Stanford. They call it the living benchmark, and we'll go into a little more detail on like, you know, what's going on here, and you know what's going on here, and they have a nice little setup, and you know, it's a good place to start, or you know, if you have corporate clients, tell them about. They like it. Everybody likes Stanford. Fewer people like open source companies that help other open source companies. So starting people off at Stanford is a solid move. So today we deployed an ArXiv. Well, we watched Chris make it look super easy to deploy an ArXiv LLM LangChain application in production style status on AWS. So easy to do that meta RAG, but it's not always super easy. If you need AWS help, look, I think there's somebody in the audience that might be able to help, you know, just look in the Zoom grid here. And then I think they're, you know, Kumar and Milan, they do this stuff all the time. So hit them up if you need help. Maybe we'll have AWS sessions in the future. Kind of falling down the rabbit hole when we go there. Be nice to Chris's endpoint. And we did eval RAGAS and Glue and MMLU, and we talked benchmarks. And hopefully that was useful to you. We will pick up next week right here, and we will also expand on prompt caching, prompt iteration, sort of a little bit more of the ops stuff. Now that we have our entire pipeline set up and we could go to production if we want, but we're just going to be operating our stuff. And maybe we'll talk a little bit more. That was a really good question, Babani, about sort of how we might leverage the framework of these metrics to sort of dial in maybe our chunking strategies or our different ways that we might build these systems. And maybe we'll talk a little bit about, non-RAG stuff as well. So with that, thank you, everybody. We are